Good afternoon, Professor Roman. My name is Yafang Zhang, and today I'm going to present my macroeconomic forecasting with quarterly time series Y3. And then let's start it. Uh, first we first we come with the time series description. The data size spans from 1961 to 2022, and Y3 is hit with notable fluctuations. From 1960s to 1980s, we observe a high volatility with sharp downturns. In the 1990s and early 2000s, we the pattern become more like stable but remain cyclical. And around 2020, Wall Street experienced a dramatic drop, followed by a repeat recovery likely reflecting the COVID-19 shocks. And then examine the distribution of Wall Street. The series is moderately left skewed with a high crystals width of 7.86, indicating flight toys and picnics, so it derives from normality. The GQ volatile strongly rejects the normality with a p-value equal to zero. This is important because many standard models assume uh, Gaussian errors. And then this is for the ACF and PACF tests. Based on the correlate Based on the correlogram of Y3, we observe significant autocorrelation starting from line 9, indicating that series is not one noise and may benefit from error modeling. To check for unit rules, I applied ADF tests and the three model setups with, like first is with intercept, and then this with train and intercept, and then this with no exogenous variables. All tests reject the non-hypothesis of a unit root at the 1% level, indicating that Y3 is integrated of order 1. The ACF and PACF plots also shows like slow decay other than sharp cutoff, suggesting that Y3 is not white noise and will be better model use area models. And then let's go through with forecasting models. So the best of ML models like the using automatic character with MRAF 2.4. Most coefficients were significant except for MA4. RMSE was around 1.37 and the 0U2 coefficient was uh 0.317, indicating like better performance than Navi focus. The focus plot closely tracks natural values through its underestimated short-term changes. In conclusion, Emerald 2.4 provides a good balance of fit and interpretability. And the second is Gauge focus. First, I use a Gauge 1.1 model based on the ratios of error model. Before estimating a catch, I verified the value was not like auto correlated and then test for Gauge effect. The Gauge LM test gave significant result, p-value equal 0, confirming the need for Gauge modeling. The Gauge model was over there, and the model captured conditional variety quite well. The focus was more responsive to variance than EMRA alone. RMSE was 1.05 and MAE was 0.78, show improved precision. And then going to the last model, which is called F3. From the VEC model, since Y3 and another variable Y4 was found to be integrated with CI2. I estimated the VEC model, the VEC equations capture both the short-run kinematics and long-run equilibrium between Y3 and Y4. And the RMSE for the forecast is 1.375. So similar to Emerald model, the forecast suggests mild growth followed by stabilization from 2021 and 2022. And then from the VC model, I generate impulse response functions. Y3 to Y3 strong and immediate self-response, peaking in period 1 and stabilizing thereafter. Y3 to Y4, a decay but moderate response, peaking 1 period 4. Y4 to Y3, strong response within 2 periods, indicating Y4 is sensitive to shocks in Y3. Y4 to Y4, strong short-term self-reaction that decays quickly. So conclusion, Y3 exerts more influence over Y4 than the reverse, and both theories display short-range memory. And various decomposition support this conclusion. Y3's science is almost entirely explained by its own innovations, like over 95%. And Y4's variance, on the other hand, is increasing that is then explained by Y3 out to like 35% by horizon 10. This shows that the Y3 is a dominant series in driving the system's dynamics. And then I create two types of combined focus. First is CF1, is average of focus from F1, F2, and F3. It captures the general trend in Y3 while but under, and underestimates extreme movements. It's smoother than any single model and offers more robust decretion forecasting. And like CF2, I used OLS to regress Y3 on F1, F2, and F3. Only F2 was statistically significant. R squared equals 7.18%, not high but better than chance. Forecast plot shows a flat focus line which failed to capture the peaks and shadows of F3. So to conclude, Y3 is a non-normal, non-stationary series with clear autoregressive patterns. Emerald VEC model provides solid baseline forecasts. Gauge improved validity modeling. Y3 strongly drives Y4 but not vice versa. Combined forecasting is useful, especially CF1, though regression-based CF2 lacks sensitive. This project shows how combined time series and the models provide deeper insight and more stable forecasts than using a single math alone. So this is all my presentation. Thanks for listening.